Welcome back, and nice to see you here. And now I'd like to invite you to a session about practical vanilla web components. I'm glad that he is here. Leon Revill from England. Have fun with Leon and practical web components.
Good morning, everybody. So first of all, I'd just like to thank the organisers for inviting me along, giving me the opportunity to talk to you guys about web components. And thank you to everybody that's come along to listen as well. So this session is a practical guide to vanilla web components. We're going to take a step back initially and take a look at what web components are. We're also going to look at why web components are so important, why you should care about web components. We're going to look at then specifically what vanilla web components are and what the benefits of vanilla web components are over alternatives. So it's a practical guide, so we're going to build some web components as well. We're going to use the next version of JavaScript to do that. We're going to build a progress bar web component and a slide out menu web component. We're going to ensure we can get our components production ready and support all of the major browsers by using polyfills. We're going to look at the browser support for some of the web component specifications and make sure that we can still support the browsers that don't yet support the web component specifications. So my name's Leon Revill. I'm a web architect, which means I can spend some of my time looking at new technologies and figuring out when best to use them. So web components piqued my interest because they had so much potential for solving some fundamental problems that we have as front-end web developers. So I've been playing around and using web components for about 18 months now, so hopefully I'm going to be able to pass on some of the stuff I've discovered throughout that time via this session to you guys. So first then, let's step back and take a look at what exactly web components are. So just out of interest, raise your hands if you already know what web components are. So a few. So who has actually written and used some web components? And who's done that in production? Cool. Okay, so hopefully I'd like to change that. So I'd like to inform people a little bit more about what web components are and inform people that they are ready for production. You can use them now and they're going to solve some fundamental problems. First of all, let's just take a look at what exactly web components are. And I think this is a decent definition. So a web component is a reusable UI widget built on open web standards that make it easy to create an encapsulated collection of HTML, CSS, and JavaScript. So when we talk about building UI components for the web platform, we're usually talking about those three things. So HTML, which defines the markup, the structure of the thing we're building. CSS, which provides the visuals, the look and feel of the thing we're building. And then the JavaScript, which provides the actual functionality of the thing we're building. So using the web component specifications, it gives us everything we need to easily create a truly encapsulated collection of these things that can easily be reused throughout your project. Okay, so why should you care about web components then? Why should you spend your time investing in web components? Well, building components for the web is nothing new. That's something we've been doing for years. It's not a new concept. Look at jQuery plugins and AngularJS directives. So they were originally designed to make it easier to reuse snippets of code across your projects. But they did have some fundamental problems. So jQuery plugins, for example, often consisted of separate HTML, CSS, and JavaScript files that all had to be maintained separately. It was often quite difficult to get going with them. And you also often have conflicts with the different jQuery plugins, with JavaScript conflicts, but also with styling as well. So styling from one component, from one jQuery plugin, would affect the styling of another. So AngularJS directives, for anybody that isn't familiar with AngularJS directives, AngularJS is a really popular JavaScript framework, and directives are their kind of implementation of components. So they were slightly better than jQuery plugins because they at least had a consistent way of keeping your CSS, HTML, and JavaScript all in one place. And they had like an isolated JavaScript scope, so you didn't get conflicts between the different components as much. But you still had problems with styling. Styling from one directive would affect another, and vice versa. So also, these two implementations of components, if you like, they were also reliant on their associated libraries. So obviously, you couldn't use a jQuery plugin without jQuery, and you couldn't use a directive without AngularJS. So it adds some additional dependencies and kind of baggage with those particular implementations. So the web component specifications basically give us everything we need to create a truly encapsulated component that's easily reused throughout your different projects. So that means we can finally solve this problem of conflicts with style and component conflicts by the web standards that provided to us via the web component specifications. So I keep talking about web components being built on top of web standards, and these are those. We have got custom elements, shadow DOM, templates, and HTML imports. They're the 4 sub-specifications which make up the web component standard. So you'll notice that templates and HTML imports are grayed out here. And that's because, thanks to some new features in JavaScript, we don't actually require these specifications to build basic web components now. That's not saying they're not useful, they certainly are, but they're not a requirement to actually build web components now, so I won't be focusing on those today. I'll just be focusing on custom elements and shadow DOM. So back to why you should care about web components then. So for me, the biggest attraction of web components is the fact that they're built on web standards. And that means that wherever you want to use your components, providing the technology using supports the DOM, you can use them. You don't need any additional libraries or any additional dependencies. And let's just take a second to think about why that matters. Well, this means that you'll finally be able to build components which are technology stack agnostic and framework agnostic. So instead of writing a component which is just reusable within the same project, you're going to be able to write components which are reusable across your different projects, regardless to what technology you're using. So if you're building applications using AngularJS and React or some other front-end framework, it doesn't matter. Because your components you're building as web components aren't reliant on any particular technologies, you can easily reuse them across those different projects. There's a little bit more to that as well. So writing your components in this way, you'll be able to transcend frameworks. So instead of, for example, anybody who's familiar with AngularJS, you might have spent a couple of years building a large AngularJS application, and now you want to move to Angular 2 or some other framework. And that's quite difficult because all of the components you've built are so reliant on that particular framework that chances are you're going to have to rewrite a good chunk of your code. But if we use web components as the building blocks of our applications, that don't rely on any of these technologies, we can more easily port those components to a new framework or a new library. So it means we can be more agile and we can keep up to date with newer technologies a lot easier, which particularly in the JavaScript community is quite important because every day there's a new library and a new framework that you may want to adopt. So using web components will give us that capability much easier. It's very difficult to justify rewriting an application commercially just to get some small benefit, but hopefully with web components, that'll make it a lot easier. So in short, web components will make your components interoperable across different projects and frameworks, not just reusable within the same project. Your components are going to have a longer life because you're going to be able to take them with you as you change technologies. So hopefully you'll no longer be tied into a certain framework for a long period of time. So let's look into custom elements and shadow DOM in a little bit more detail, just so we can understand exactly what these specifications give us. So custom elements then, so this is one of the specifications which makes up the web component spec. And that basically allows us to define our own custom DOM elements. So just like with H1 tags and P tags, we can define our own custom element, which is how people use our web component. So in this example, we've created a custom element called Rebel Slide Menu, which is the slide menu we're going to create shortly. And that means it'll work just like all of the DOM elements. And that means that people that want to use our web components don't have to be introduced to anything new. They're just going to use it like a normal DOM element. They don't have to understand any complicated JavaScript initialization somewhere else. They just use it like a normal DOM element, which means there's less friction for somebody using our components. And also, our web component, our custom element, is going to work and function just like other DOM elements, so it'll be very familiar to them. So, the shadow DOM specification. This is another sub-spec that makes up the web component standard, and is arguably the most exciting. So the shadow DOM basically allows us to create a self-encapsulated sub-DOM tree for our web component. And that means that using the shadow DOM, we're going to be able to easily prevent any of the application styling from leaking into our component. So in this example here, we have a normal HTML document. We have got our countdown web component. And then inside that web component, we've got our own shadow DOM, and that's a sub-DOM tree. So anything inside this shadow DOM, which is part of our component, isn't going to inherit any styles from the main application. And equally, any styles we put inside our sub-DOM tree isn't going to leak out into the outer application. So that's how we solve those styling conflicts. So as an example, if we put some styling in the header of the main application, which set anything with a section class to say blue, then this isn't going to inherit that and not be affected. And equally, if we put any styling in here, that's not going to leak to the outer application. So this has got some quite significant benefits. So it means that we can have complete confidence that people using our web component, it's not going to break their applications. And equally, we can have confidence that when people include our web component into their applications, their styling isn't going to break our web component. And this also means we've got confidence when we want to upgrade our components. We know we're not going to break anything, so we can do that more easily. So now we understand a little bit more about what web components are, some of the benefits. You can get true encapsulation, for example. Let's talk about kind of what I mean by vanilla web components. By vanilla web components, I just mean plain JavaScript, no additional libraries or other dependencies, just the web component specifications. So for a while now, there's been a few web component libraries that aim at making building web components a little bit easier. And these are probably the most popular: Polymer, Skate.js, Xtag, and Bosonic. So these web components, these web component libraries, some of them came about initially because the web component specification wasn't completed, it wasn't well supported. So these libraries aimed at solving that problem. Okay, so these libraries basically make it possible. They filled in the gaps that was missing from the specifications. They made it possible to write web components and use them across all of the major browsers. And they also add some additional benefits. So they'd add some additional features such as data binding and things like that, which basically made building things with web components a lot nicer. And Polymer in particular, it's much more than a web component library. It allows you to build entire applications and also progressive web applications. And I think there's the Polymer session on the schedule, which I'd encourage you to go to learn more about Polymer. But if these libraries are so good, why am I talking about vanilla web components then? Well, there are some significant benefits to using vanilla web components over these libraries. First and foremost, each of these libraries presents a slightly different way of building components. So you couldn't write a Polymer component and use it with Xtag and vice versa, which means you are losing some of that interoperability, some of that reusability that we identified as quite important early on. Additionally, you're going to be tied into those particular libraries. So if you write a Polymer component, obviously anybody using your component is going to need to include the Polymer library as well. So if we wrote a simple progress bar component using Polymer and somebody didn't already use Polymer in their application, they would have to include that additional dependency, which just adds a little bit more friction to using your component. Whereas if you're building vanilla web components, you've got total freedom. You've got proper interoperability, portability, and you're also going to have a deeper understanding of how the technology works underneath, which is quite important. It's also worth mentioning that the specifications for custom elements and shadow DOM are now in version 1. They've now been defined and finished, and the browser vendors have agreed to implement these new features, which means it's much easier for us now building vanilla web components. Equally, we can make use of the same polyfills that these libraries use to make sure that our vanilla web components will work across all of the major browsers. So, hopefully by now I've convinced you that web components solve some specific problems. The takeaway is that with web components, we can get true encapsulation with the shadow DOM, we can get portability and interoperability, and the capability of finally writing longer life, framework-agnostic UI components. So, how do you build vanilla web components then? So, we'll do that by utilizing the next version of JavaScript. So currently, all browsers support ES5, which is the current version of JavaScript. With the next version of JavaScript, that's ECMAScript 2015, 2016, and 2017, we get some additional benefits that makes building web components a lot easier and then generally makes writing JavaScript a lot nicer. Some of these benefits are classes, modules, template strings, arrow functions, etc. And we'll be using some of these to build the two components in a little while. And that's exactly what we're going to do, is make sure we utilize the next version of JavaScript. So, before we jump into some code and start building a web component, I first want to introduce you to the basic anatomy of a web component. And it's worth mentioning that throughout this session, we're going to be using the version 1 APIs of Shadow DOM and custom elements, and they're very new. I think they were finalized only a few months ago. So if you do any research online about vanilla web components, chances are that you will see content using the version 0 of those APIs. So it's very important to ensure you're using the latest APIs to build out your components. So this is a basic skeleton. Don't worry if you can't see it. We're going to zoom into each section in a little while. But at kind of the top level, we basically are using a ES2015 class, which will represent the prototype of our web component. And then at the bottom, we're going to that's how we define our custom element. And inside the class, there's some methods we can use to build out our component. So if we start out with the class definition, so the first thing is we give it a meaningful name, of course, so it's my component in this example, and then we extend HTML element. So the reason why we extend the HTML element is, remember me saying that our web component is going to work like all other DOM elements? Well, all other DOM elements ultimately inherit from the HTML element interface. And that gives us all the properties and methods that you'd expect in our DOM element, such as offset, client width, and all those kind of things. Now, we don't need to extend HTML element. We could extend HTML div element or HTML unordered list element or any other DOM elements if there's any particular functionality that we need. We can also extend other custom elements. So after we've built this my component custom element, we could then create another class which extends from that and inherits the same functionality. So it's quite extensible. At the bottom, this is how we define our custom element. So this is how we tell the browser that we want to make available this new DOM element and tell the browser how it should work. So again, using the version 1 of the custom elements API, we do custom elements.define, give it our component name, so it has to have an hyphen in it to make sure it's unique. And as a second parameter, we provide the class that we've created, which represent the prototype of our custom element. Inside of the component class, we have a few methods we can use. So the first one, because it's a class, we use the constructor, and this method is going to get executed when our custom element is added to is created. This is where we can add some initial markup to our component, or we can add some local class properties that we can use later. We call the super function because that's going to be called the constructor of the parent, and if we want to refer to this anywhere in the constructor, we have to call that first. So we just add that by default. So using the custom elements API, we have a few callback methods available to us to help us build our web components. The first one is the connected callback, and this method gets executed when the custom element is added to the DOM. And this is where we can do some initial rendering to get some property values or set up our component for use. The next callback we have available to us is the attribute change callback, and this is a very important one. We'll use this quite a lot, and we'll use this building our progress bar component shortly. But the attribute change callback is going to get executed when one of the attributes on our DOM element is modified. So for example, if we added a percent attribute to our custom element, this method's going to get executed. The name would be %, then we're going to get the previous value of that attribute, and then we're going to get the current value of that attribute, and we can then compare those and then do something inside our component. And the final callback method we'll mostly make use of is the disconnected callback. So this is the complete opposite to the connected callback, where this is going to get executed when our DOM element is removed from the DOM. And this is where we can do some cleanup, such as if we used a set interval in our component, for example, this is where we can clear that interval and make sure that's not still executing even when our web component is removed from the DOM. So that's the basic skeleton of our component. This is what you're going to use time and time again when you start building your component. It's a good starting point. So now we know exactly, now we know the basic anatomy of a component, we can start building an actual proper web component. So the first one we're going to build is a progress bar. It's available at GitHub via that link if anybody wants to go and check out the code now or afterwards. It's going to be a very simple component. It doesn't use the shadow DOM. It's going to observe element attributes using the attribute change callback, and then we're going to update the contents of that component based on that value changing, which you can see down at the bottom. So a really simple component, and that's what we're going to build next. So the first thing we're going to do is we're going to start out with our skeleton. So very similar to what we just saw earlier. We're going to create a ES2015 JavaScript class. We're going to call it Revill Progress Bar. So Revill is just a prefix I add to all of my components. Obviously, you want your custom DOM element names to be very unique. So that's why we try and keep a unique name, because you can't have two components with the same custom element name. They won't be able to be used in the same project. Then we're going to extend HTML element interface. We don't want any special functionality, so we'll just extend that. Then we're going to use the constructor, we're going to use the connected callback, and we're going to use the attribute change callback. We don't need to use the disconnected callback for this component, so we're going to ignore that completely. So the first thing we're going to do then is we want to add some initial markup to our web component. So when the browser creates this component, it's going to run the constructor first, and then what we're going to do is we're going to add some initial markup using inner HTML. So remember, our web component behaves just like a normal DOM element, so we have access to inner HTML, where we can basically provide some HTML markup. Notice here I'm using another ES2015 JavaScript feature, which is template strings, indicated by the backticks, which just means I can write HTML inside my JavaScript. I get proper syntax highlighting, and it's much nicer than what it would normally be in ES5. So the actual markup we're adding is a container element, which is basically just going to be the progress bar container with some shadowing on it. We've then got an element which is the fill, so the green thing that will kind of change its width based on the percent. And then we've got a number element where we're going to put the actual textual number reference. So if we rendered that in the browser now, this is what it would look like. We've got our custom element, and then so when it called the constructor, it added some initial markup to the innards of our component, and we can see that being added there. So notice we've added a percent attribute to our component as well. And if we actually render that in the browser, thanks to the styling we've already added, that's what it's going to look like in the browser. But we're not representing the 90% that from that attribute there. So what we need to do is when our component gets added to the DOM, we need to grab that value and update the component accordingly. To do that, we are going to create a custom method on our class called render. And all this is going to do is it's going to define a percent constant, which is going to use the getAttribute property. Remember, we're just dealing with a normal DOM element here. So we can then grab the percent attribute from our custom element. If that value isn't null, what we can then do is select a few of the elements inside our component and update them. So the first one we're going to do is we're going to select the number element and set the inner text to the percent. So that's the value coming from the attribute. We use query selector, which again is a normal method available on DOM elements. And then the next thing we're going to do is grab the fill element and update its width to represent the percentage. So now, as we said, we want that to actually happen when the element is first added to the DOM. So we can do that by calling the render method from the connected callback, remembering that the connected callback is executed when our DOM element is added to the DOM. Now, when we render that in the browser, it's going to look like this. So when it gets added to the DOM, it's going to call that render method, which is going to get the value from this attribute. It's going to set the text of that element there and also change the width of the fill element. So now it starts to look a little bit more like a progress bar. A progress bar, though, isn't going to have a static value. The whole point of a progress bar is that it's updated over time depending on something that's happening in the application. So what we need to do now is be able to react to changes when that attribute value changes. And we can do that by using the attribute change callback, which we looked at earlier. So we've done something additional here. So to be able to make use of the attribute change callback, we are using the observed attributes method, and we have to return an array of strings. And the array of strings, the strings are the names of the attributes that we want to observe, we want to look out for. And what we're doing here, because the only attribute we care about in this example is the percent attribute, we just specify percent there, and that means now that this callback method is only going to get executed when the attribute value is changed. And then that means we can just call this.render, which is going to call that function and update our component accordingly. And that's basically it. So we can see that working here. When you change the percent attribute value, that's going to then call the attribute change callback, which in turn is going to call the render method, which is going to get the new percent value, and it's going to update the component. And then that's going to be reflected in the component itself. So that's an example of a very simple web component where everything's encapsulated into one place. We create a custom DOM element that's really easy for people to use. We used ES2015 features such as classes and template strings to be able to build that component. We make use of the connected callback to do some initial rendering updates when the component is added to the DOM. And we use the attribute change callback to react to changes of those attributes. So that's all well and good. But what about, we've used ES 2015, which is the next version of JavaScript, and not all browsers support all of those features yet. So what we're going to need to do is we're going to need to transpile our ES 2015 code back to ES5 so that all of the major browsers can understand it. Well, that's really easy. So assuming you're familiar with NPM, Node Package Manager, which allows us to easily install CLI tools, we can install a CLI tool called Babel, and that's basically going to do the transpilation for us. With a single command, we can install that tool and then install a preset, which comes with Babel, which allows us to install a load of things that we need to do the ES 2015 to ES5 transpilation. And then once you have done that, when you've installed that CLI tool, you can just run another command which tells Babel to use those presets you've installed. You then point it at the ES 2015 web component file, the one we've just created. And then we specify where to output the transpiled ES5 code, and then that's the file that we'll use in our projects, because then it'll be ES5, and then it's going to work in all the browsers which don't yet support all of the ES 2015 features. So it's worth mentioning that if there was a TypeScript session earlier this morning, if you went to that, if you were using TypeScript to build your vanilla web components, which is perfectly possible, then you wouldn't actually need this step at all. So TypeScript would take care of that transpilation for you. Okay, so now we've got our new JavaScript back to ES5, so all the browsers are going to understand it. But what about specification support? So what support is there currently for the web component specifications? So first of all, let's look at custom elements, and it's not looking particularly good. So obviously Chrome supports it. It's available behind a flag in Firefox. There's no IE and no Edge support, and Safari doesn't support it either. So in a moment, we'll look at solving that problem, but let's have a look at the support for Shadow DOM. So a similar story, Chrome supports this feature. It's available behind a flag in Firefox. Again, no IE and Edge support. But interestingly, the next version of Safari provides complete support for the version 1 of the Shadow DOM. And that just shows that these different browser vendors are adopting these new features. And it's not a matter of if, it's a matter of when. These browser vendors have decided and agreed to adopt these specifications, so it's just a case of waiting for that. But we don't like waiting, so how can we get our vanilla web components working across all of the major browsers without having to wait for them to support it? So we can make use of some polyfills. So there's a suite of polyfills called Web Components.js, which basically provides polyfills for the four specifications which make up the web component standard. So a note on these polyfills. So these polyfills aren't something new and untested. They're very performant. They've been around for years. They're used a lot. So there's absolutely no reason why you can't use them in production. I do. There's nothing to fear them. They're a good set of polyfills. And by using those polyfills, we can get partial support for IE10 for custom elements, and then IE11 and above, and including all of the mobile browsers as well. And we can also get complete support for Shadow DOM from IE10 and above. A note on Shadow DOM, though. So because the Shadow DOM is such a fundamental part of browsers, such as part of an actual feature, we can't entirely polyfill that. That's not something that's possible. So what it means to polyfill Shadow DOM is that any components you create which use the Shadow DOM, which we're going to do shortly, they will work in the browsers that don't support Shadow DOM yet, but you're not going to get the encapsulation benefits. So we are going to have to wait a little bit longer for that. So the second link on this slide is a consolidation of the version 1 APIs. So because the version 1 specifications are quite new, if you wanted to go and grab the version 1 API polyfills from Web Components.js, you'd have to go digging for it. You'd have to look in a few different branches, etc. So the guys at Skate.js, so remember that's one of the Web Component libraries we looked at earlier, they've basically created a consolidation of all the newest polyfills, so that means that we can easily just use a single file in our projects, include that at the top of our page. We don't need to go looking for anything, and we can use it nice and easily. So we add that into our page, and our components, after they've been transpiled to ES5, are going to work in all of the major browsers, no problems. So now we know how to build a basic web component. We know how to transpile it to ES5, so it's going to run in all of the major browsers, and we know how we can use the polyfills to make sure we can actually use these web components in production. So that moves us on to our next component. So this is going to be a sliding menu component. Again, it's available on GitHub via that link if anybody wants to take a look. It's going to be a more complex component. So it's going to build on top of everything that we learned from the previous component. This time it's going to utilize the shadow DOM, so one of the more exciting features of the web component specification. It's going to use slots for content projection. So that means that we can basically provide a way of users specifying content to go inside our component. And we're also going to use CSS variables for styling. So you can see the component working on the left-hand side. It's just a simple slide-out menu. It's got a title and a content area and a close button. So obviously people can close the menu. So starting out then, once again, we start with our JavaScript class, our web component skeleton. This time, we're only going to make use of the constructor and the connected callback. We're calling it Revill slide menu, again, extending HTML element because we want it to function just like another DOM element. And at the bottom, we define our custom element and specify that class. Inside the constructor, we're just declaring a few class properties. We've got an open variable here, which is just going to basically keep state of our menu, whether it's open or closed. And then we've got a few other class properties, which are going to keep reference of some DOM elements, which we're going to use later on. So because we want to use the shadow DOM, the first thing we need to do is basically create a sub-DOM tree for our web component. And we do that by calling the attach shadow method. So this is referring to our custom element. Then we call attach shadow, which is going to create the encapsulated sub-DOM tree for our component. And we also specify a mode. So there's two modes of shadow DOM, open and closed. So you're probably never going to use the closed mode because the closed mode doesn't allow you access to any of the insides of the sub-DOM tree, which is typically what you're going to want to do when building a web component. An example of closed mode is the HTML5 video element. So that's just a single tag, and you can't style it, you can't access its internals in any way, and that's because it's using the closed mode. So we're going to go ahead and use the open mode. So the next thing we're going to do, just like we did with the progress bar component, we're going to add some initial markup to the inside of our component. But this time, instead of just attaching it to inner HTML, we're going to first access the shadow root. So that's the sub-DOM tree that we've created using the shadow DOM. So we do this shadow root.inner HTML and then specify the initial markup. In this initial markup, we have some styling, which we won't go into in any detail. We have a frame, and that frame is going to cover the entire application and give us that modal effect when the menu is open, using a black opacity effect. Then we have our nav bar, and in that's the nav bar, which using the styling we've added here, it's going to be positioned negatively off the left-hand side of the screen until the menu is opened. The way we open the menu is we just add an open class to the frame, and then that's going to use CSS transitions to animate the menu back in. So inside the nav bar itself, we've got a title area, a close button, and we've got then a content area. So before we move any further, I keep talking about how Shadow DOM solves some styling issues and doesn't inherit style from the main application. So let's just take a look at an example of exactly how that works. So this is a simple example here. We have a normal HTML document running in a browser. We have got some styles in the main document, which is basically setting all H1s to red and saying that that's important. Then in the main body, we've got a H1 tag. Then we've got a web component, which is using the shadow DOM. So it's got a shadow root. In that shadow root, we have a H1 tag, and we've got some more styles setting H1 to blue. So anybody that's familiar with CSS will know that if you specify a CSS definition as important, it means that any further when you specify H1 and the color further down in that document, it's going to be ignored because that is to take precedence. But because we're using the shadow DOM, anything inside this shadow root is not going to inherit any styles from the main document. So that means that when we actually look at it rendered in the browser, the main document's H1 tag is red, but the web component's sub-DOM tree H1 tag is blue because it's specified to be blue there. But equally, if we remove the styling from the shadow root entirely, it's still not going to inherit the H1 tag CSS there. It's not going to inherit it at all, so therefore it's going to default to the browser default, which in this case is black. So that means we've got complete control over what our component looks like. We don't need to worry about any application styling leaking into our component. And equally, if we add any styles to our shadow root, we don't need to worry about it polluting the outer application. So now we're clear on the effects of the shadow DOM in regards to styling. Let's get back to building a slide-out menu component. So the next thing we're going to do is we're going to add some code to our connector callback. So remember, the connector callback is executed when our DOM element is added to the DOM. And the first thing we're going to do is we're going to go and select the frame, because that's what we need to add an open class to. And we do that by calling this.shadowroot.querySelector. Again, remember, we've put this markup inside the shadow root. So we need to do query selector on the shadow root to get at that element. We're also we're going to store that as a reference to the frame property, so we can use that later on in our component. And we're also going to select the close button and store that as a reference on a class property. And we're also going to add an event listener so that when somebody clicks on that close button, we can then call a local close method, which we're going to implement next. So the next thing we're going to do is we are going to add 3 custom methods to our class. Open, close, and isOpen. They're pretty self-explanatory. So the open method, when it's executed, is going to add the open class to the frame, and it's also going to set the open flag to true, so we know when the menu is currently open. We're going to add a close method, which basically does the opposite to open, is remove the open class from the frame and set the open flag to false. And then the isOpen method is basically going to return true or false, depending on whether the menu is open or not. OK, so this is how we are going to use our slide out menu component. So this is just a normal HTML document, so call it index.html. We then include our component at the top there and give it an ID of menu. In this page, we've also got a toggle button. Obviously, you want somebody to be able to open their menu in some way. And then we've got a little bit of JavaScript at the bottom. So to actually use the interface that we've built for this component, we can select our component using its ID. Then when somebody clicks on the toggle button, so just by adding an event listener and specifying click there, we can literally call those methods that we've created on our class. So remember the isOpen, close, and open methods we created. We can literally call those directly on the element we selected. So in this example, we call isOpen to figure out if it's open or not. If it's already open, we then close the menu. If it's not already open, we're then going to open the menu. Obviously, we could have moved this functionality inside the component itself and just added a toggle method onto our web component. But that's going to just illustrates the point that you can just call those methods on the class that we've created, basically allowing us to build up an API. So that's what the component looks like if rendered in the browser. So not particularly useful. It's got a default title of menu, and there's no content in there at all. So what we want to do, we want the user first to be able to specify the title that they want, but we also want them to be able to specify the content of the component. So we want that content to be anything. We want them to be able to add a list of links or some other HTML or an image if they wanted to. We want them to have control over what it is they add in there. And that's where slots come in. So as part of the Shadow DOM version 1 API specification, we have something called slots, which basically allows us to create placeholders for user-specified content. So if you see here, you might have noticed earlier we added these slot elements. So we're back in the class where we're building our component. And inside the initial markup, we added some slot elements. And we give those a name, give them something meaningful. So in this case, we've got a slot for title and a slot for content. And what that means is that we're basically, we have control over where a user can specify content for our web component. And how they do that is, so again, this is back in index.html where they're using our component. They can then write some HTML as children to our custom element and then basically tag it with the slot attribute and say, this should be the title, and then tag it with content and saying, this is what the content should be. It's as simple as that. And that gives us as component authors complete control over what the user, where the user can add content. So they can't just stick it anywhere. We have control over what capabilities they have. And that's basically going to project that content they specified into these placeholders we've created. So this is what that would look like if rendered now. So you can see that we've now got the navigation, the title changed to navigation from menu, and we have got the list of links there, which is specified as content. If we just go back a slide, what I forgot to mention is you can also specify defaults with slots. So as you can see here, we specify some text inside the slot element as menu, and that's what it'll default to if a user doesn't specify any content for the title slot. So because we added some styling for the title inside our component, and that looks quite nice, but the content here doesn't look particularly good, but that's by design. Because we want the user to be able to add whatever content they want, we also want them to be able to style it however they like. But how are they going to do that if the shadow DOM doesn't inherit styles? Well, that's part of the beauty of slotting, because it keeps the content outside of the shadow root. So as you can see here in the DevTools, you can see that the actual slotted content, even though it appears to be in the placeholder areas, it's actually kept outside of the shadow root, which means the user can style it how they would normally do. So in an example, we just had some CSS specifying the element tag name, and then they can style that list however they like. And not only the content is projected into that area, into that placeholder we specified, the styling is as well. So now you can see the styling looks quite nice, and they've got complete control over that. So what about the title bar then? So the title bar we created, that's part of the initial markup of our component that is within the shadow DOM. So the user doesn't have control over that. But what if a user wanted to use our slide out menu and their app theme was red, for example? Well, having a blue title bar isn't going to be very, very good for them. And this is where we can use CSS variables. So by using CSS variables, we can basically build a styling API. And again, like we did with the slots, we can basically have complete control over what a user is able to style inside the shadow root of our web component. So here, back in our component class, and inside the style tag, we can then specify some CSS for our title menu. We can say the background color should be whatever this CSS variable value provides. If that isn't available, we can provide a default. So just like with slotting, we can provide defaults for these things. We can also provide a default for the CSS variables, so it'll always fall back to something useful if a user hasn't specified that. So that means that when a user wants to change these CSS variables, just by adding some normal CSS using the tag selector, so that's the custom element of our web component, they can then basically set up that variable that we specified inside our component, change it to whatever value that we like, and then our component is going to pick up that style. So again, we can build out an API that is going to allow users to theme the components. Again, as a component author, we've got complete control over what they can change, so we can still ensure that our component is used as it is intended, but still gives the flexibility to the user. The bad news is, though, that there's no IE or Edge support for CSS variables currently, which is a shame. The good news is, though, is that it's supported by all of the major browsers. So it does mean that you're going to get it working in Firefox, Chrome, Safari, the mobile browsers as well. But unfortunately, we are going to have to wait a little bit longer until IE and Edge support that. So that concludes our sliding menu. So that component built on top of the progress bar component that we built initially. It built on top of what we learned from that. It showed us how to use the shadow DOM for true encapsulation. We actually looked at exactly how the shadow DOM works as an example of how it doesn't inherit styles. We used slotting to provide placeholders for user-specified content, and we also looked at how we can use CSS variables and CSS custom properties to provide a styling API. Which again gives us control over what the user can style, and also ensures that we can actually make our components themable, which is very important for using them across different projects. So that's actually near the end of my session. It's actually taken a lot shorter time than I expected it to. But in summary, so hopefully you now know that web components solve fundamental problems. That's true encapsulation with the shadow DOM. So until the availability of the shadow DOM, we've not been able to solve the problem of CSS leaking and other styling issues. So now with the shadow DOM, we've finally got control over that, and we can finally solve that problem. With vanilla web components, we can write longer life framework agnostic components. So it means we can write components that are not only easily reusable within the same project, but also across our projects, regardless to what technology we're using in those different projects, which is a really big problem that we need to solve, particularly with how quickly the JavaScript community churns out new things. So we've learned how to build basic web components using the latest version of JavaScript. So we use ES 2015, some features we use classes, templates, strings, and the like to help us easily build these web components. Importantly, we have used the version 1 specifications of custom elements and shadow DOMs. So that's the very new stuff. So that's what all the browser vendors are going to adopt. So we understand how to use those to build our web components. We've learned how easy it is to get our components production ready by doing the transpilation and also using the polyfills which are available to us. We've understood how to use the shadow DOM in our components. We've made use of slotting, and we've also used CSS variables for styling to be able to make our components themable. Okay, so hopefully I've piqued your interest enough to want to go and learn a little bit more about web components. So the go-to place is webcomponents.org. There's a big community around there. There's loads of really good articles, loads of really good tutorials. There's links to the specifications, links to the polyfills, links to video tutorials, and all those other kind of things. So that's the first place you should go to learn about web components. So I keep saying that the shadow DOM is such an important part of the web component standard and obviously solves quite a lot of problems. So I've included two links to 2 articles here. I'll tweet these out and obviously make the slides available best way we can so people can get hold of these links. But the first one is by the Google developers, Shadow DOM version 1, self-contained web components. So this article really goes into detail about what the specification includes, what its capabilities are, in much more detail than obviously I've been able to during this session. It also has some advanced topics there as well. So that's a really good article to go and read to be well informed on the Shadow DOM specification. So the second article, I keep saying that we're using a version 1 specification of Shadow DOM because mostly if you go and look at some content online at the moment about vanilla web components, chances are it's going to be using version 0, and there is some breaking changes there. So this next link provides examples and comparisons of version 0 and version 1, so you can really see the difference and make sure you're using the very latest stuff which all the browser vendors are going to adopt. And finally, if you actually want to see some examples of vanilla web components, my GitHub has got a few on there. I'm always writing new vanilla web components. Again, the 2 examples we've just seen are also available on GitHub. So please take some time and go and take a look, and hopefully you'll see some good examples on there. On resources, there's a podcast called the Web Platform Podcast. I'm lucky enough to be a regular panelist on here, and it's very much focused towards web components. So we have some really good guests, including people from Google and from Microsoft. We had the Microsoft Edge team on only a few weeks ago, talking about what their plans are with the web component specifications. So there's lots of really useful information in this podcast, lots of very current information about web components. So I'd recommend you go and check that out. And finally, one last thing from me. I'd like to bring your attention to a project I'm going to be starting very soon, which is FormTime.js. So it's an open source web component library, which is aimed at making building out web forms really easy. So whether you're building a website or an application, at some point you're going to have to collect user data. So this open source library is going to be built using vanilla web components. So it means they will work across all of your different projects. They'll be very performant. We're going to have designers involved to make sure they look amazing, make sure they're themable, obviously using some of the technologies that we saw earlier. And if you go to formtimejs.com now, you'll see a landing page with some additional information on the features of this library, and you can also stick your email address in there, so you'll get updates when we start working on this project, and hopefully you'll be able to pick it up really, really soon. So that's it. Sorry, it's not taken the full 60 minutes. Don't know how that happened. But is there any questions? At least that means there's plenty of time for questions.
Any suggestions how to test web components?
Well, because it's just JavaScript, and ultimately you're just building DOM elements, so a lot of the JavaScript testing frameworks should work perfectly fine with web components. And because they're very self-contained, it should be very easy to test them. So I'm not an expert in testing at all, so I don't have any further suggestions. But because it's just JavaScript, it's just DOM elements, and you shouldn't have any problem testing them. Obviously, that's a very important thing.
As you said, CSS variables aren't currently supported by IE team. Is there some workaround to use web components with IE? Otherwise, it's not usable in production at the moment at all.
Well, it's actually not quite true, but because IE and Edge don't currently support the shadow DOM, then because you don't get the encapsulations of the shadow DOM, they can actually style those internals any way they like. So actually, you can still use normal CSS because IE don't yet support the shadow DOM. So that's not actually going to be a problem, if that makes sense.
Okay.
And of course, it's worth mentioning on that note that there is other ways to allow people to style your web components other than CSS variables. So for example, a simple theming example would be maybe you can allow them to provide a primary color and a secondary color attribute on that component, which it then takes in and renders the CSS that way. And you can also include external style sheets directly into the sub-DOM tree, and then it'll inherit the styles that way. So there are alternatives to CSS variables. CSS variables are just going to be the way that you would do it once we've got full support across the different browsers.
I would be interested, you showed on the slide that Safari removed support for Shadow DOM. They used to have it in there and then removed it, or did I get it wrong?
No, so Safari, did you say?
Yeah.
Yeah, so the next version of Safari will have full support for the version 1 Shadow DOM specification. Sorry, I didn't make that very clear, but it means the next version, that's Safari 10, they've got full support for that specification,
okay,
which is good news for us.
Okay, thanks.
Any more? No, so if you think of any more questions, come and find me at lunch or talk to me on Twitter. I really love talking about web components. If you have any ideas or any suggestions, please let me know. So, thank you very much.